So this is the Gary version of what you did.
Bad.
I look at main new window. Isn't that exciting? You gotta take it simple with your life sometimes, Sarah. You know?
Yeah.
Okay, so let's close the door. Let's get into this because trying to write another package in a whole hour, we'll have to not mess around. Oh, I found a tea bag.
Oh.
It's been in my back pocket. I think that's a tea bag we're never going to use. Or when someone says I don't like a cup of tea, I go, there you are.
What type of tea though?
Well, it's
left
this left arse cheek. Yeah. It's a bit dark Eden. Everyone goes, that's a bit smoky, isn't it? And I go, yeah. Hey, you don't want to know why that is. Okay, so what we're going to do is we're going to look at how you write an R package. Okay, so you probably need these tools. So we're going to start by just creating our package. I'm going to put mine on the desktop. So the first command we're going to do, you're going to use this package. And there's a thing called create package. I'm going to put mine on the desktop and call it John O'Mean. So that's going to be the name of my package. So you feel free to call your package whatever you want and put it someone. Yes, I get the pun. I call it John O'Mean. See, it's a, yeah.
Good.
It's a classic, isn't it?
I give it a 3 out of 5.
A 3 out of 5? I'll have to work harder. So, so when you run that command, it should give you a load of stuff, which isn't appearing there. That's really weird. No, that looks good. So, and what it should do is it should create you a project. So if you look in the top right, it says John O'Mean, and you've got this general structure. First of all, packages in R are just a folder with a particular structure. There's nothing more special than that. You just have to make sure you put things in the right place. Okay? So, cool. Next thing, we're going to go into a thing called a description file. So if we go and have a look at our description file. So if you go here, there's a file called description. You click on it. And this is where you put all the information about your package. So you can see that you've got what the name of the package is, what it does, your version. You can put in your details of who you are, your description, so a paragraph of what your package does. The license. The license basically says if someone uses a package, can everyone use it, or do they have to pay you and stuff like that? You can go search the information on licenses. I use the GPL3 because when I read through, it seemed to be the one that said, please, you can use it. If you use it, acknowledge me. But people know more about licenses. Go and have a chat to people about the licenses. So I'm going to cheat. I'm going to cheat badly. I do apologize. To help you save time, there should be a zip file called package material that I put on, which will give you various bits. So here's my description, like that. I'm just going to copy it and go to my John O'Mean and paste it. Okay. Ignore the imports ggplot2. I'll show you how I got that in a second.
Hang on. Where's the text file? On the website?
There should have been on the text file a zip file called workshop material or something.
Yeah, description.txt.
Yeah.
Cool. Apologies.
Okay. I'll give you a couple of minutes to copy and paste or put your details in, whichever you want to prefer to do. Now, obviously, if you don't get everything done today, it doesn't matter. I mean, you are going to write a package for your assignment, just go back and clean it and make sure it all works. So, at this point, we have almost nothing in this folder, but we can still build our first package. So to do that, if everything's going right, you should have a thing up here, a tab called Build. So I click on build, and there is a button called install and restart. You press it. It does some stuff. If you don't get a lot of red over there, you're pretty good. It's built it, and then over in the console, you can now see it goes library John O'Mean, and you just made your first package. Very much. That's it. It was a short workshop, but I suppose we should put some stuff in it. So you can actually check that you have a package now. You can go to your packages tab, and in there, if you go down, if you are lucky, it will say John O'Mean, and it's loaded it. You can see mine says calculates the sample mean, and if we clicked on that and we went to description file, here's my description. And that's going to be it. We're slowly going to add things to this folder structure, and we're going to go and say build. Now, rather than typing or clicking on the install and restart on a Mac, it's Command-Shift-B. On a non-Mac, I don't know. Go to keyboard shortcut and it will tell you. Cool. Any questions? So, we want to add functions to our package. All functions are going to go in the folder that we got automatically given at the start called R. So if we go back here, we go to the files, you'll see that within this project there's a folder called R. If you click on that, at the moment it's empty. But anything we put in there will be the functions, so you could have all in one file if you wanted, or multiple files, it doesn't matter, but whatever's in there, it will basically convert to the functions of your package. So let's do that. Let's just go File, New R Script. We're going to put in here our my mean function. So I'll copy that. I will paste it. And then I will save that in the R folder. So it's in the R folder. Now I often call the file name the same as the function name, and I usually go for one file, one function. The only time I break that is if I have a lot of very related functions that do one thing together, I will have one file for that related thing. So you click Save, and now if we built that, we would have a function in there. But we have an undocumented, really, really bad function. So we actually want to improve that. So we're going to add documentation. Now there's two ways you can add documentation. You can actually create yourself a handcrafted folder called man, and in that you can actually sort of a pseudo LaTeX way of creating your help functions. And this is how we used to do it. As someone who's actually done a whole package doing that, I highly recommend you don't do that. Instead, there's a thing called Roxygen. Roxygen is a derivative of a thing called Doxygen, which comes from, I think, in Python or the other languages, that lets you have comments that get automatically converted into your help file. So how do we do that? Well, we're going to go back to my mean. You make sure, let me just tidy this up because I just copied and pasted it. So let me just make this a bit cleaner.
How did you do that?
Do what?
The little indenting.
Command I.
I think you said it one line at a time.
Yeah, you can do the whole lot. I can't remember the whole command. I think if you highlight the whole lot and go Command I, it will do the indenting. So I make sure I'm inside the function. So my cursor is inside the function, and I go up to Code, Insert Roxygen. And you click that, and it should produce something that looks like this. So first of all, Roxygen has a hash and a single quotation mark. And the structure is, the first line is going to be the title, it should be just one line. Then you have a space, and then you have a description, and then you have space. And then it does these key value pairs. So here it says @param, so it's automatically looked at my function, seen as a parameter, and added one in. And it says @param, it's called X, and just next to that you're going to say what it is. You're going to give information. So you might say, for example, with this, it is a, numeric vector. Like that. Return, you can say what it returns. So in our case, it returns the sample mean. Export is there. Basically what export does says that when people use your package, this function should be available. So if you don't have export, you can actually have hidden functions. You can still get to them, but they're not, they don't put like help pages and everything. You can also put examples. In fact, if we go back to my ADS and look at my mean, here is a better mean function. So you can see I've got the name, it's a sample mean. The function takes a vector and calculates the sample mean. I've got a single parameter that goes in x, which is a numerical vector. It returns the sample mean, it's export. And also I put examples, and I have some examples here. This is code that you can run in your package when you load it. Okay. Now, there's two ways you can convert this to documentation. There is actually, over here, if you go back to your build thing and look, there's a thing called document. Hello. But we're not going to do that. What we're going to do instead is we're actually going to think about making it that every time we build it, it will make our documentation, it will update it. So to do that, we're going to go more, and we're going to go to config build tools. Click on that. And first of all, you make sure that this is ticked. Generate documentation with Roxygen. That's fine, that's ticked, so it's going to use Roxygen. If you don't have Roxygen installed, it will say you need Roxygen 2, is the version you want. But I'm going to go configure, and I'm going to say, yes, I want you to build everything, and I want you to do it every time I click the build button. So now when I click the build button, it should actually go, oh, I better save stuff. It says, look, I'm updating, if we go back and look up here, I'm updating the documentation using Roxygen, blah, 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 loading John O'Mean, it's all done. And again, as always with these things, if it works, won't always work, but if it works now, when I go to my John O'Mean function, I now have a thing called my mean, sample mean, and when I click on it, I should now have a help file. No?
Can't load John O'Mean. No.
So what did it say when it says can't load John O'Mean?
Error int/xdata/World Cup 2010. I downloaded all the files from the internet.
Yeah, no, don't do that. Move them across one by one. Yeah, sorry. So we have probably the best package known to man so far. It has a description file. We've claimed credit for it. I don't know why we bothered claiming credit for this so far, but we have a single function there that will do a thing that we already had, but it's documented. And to some extent now, this is what you do. Often what I would have done is I would have had a whole, a folder or project with a load of functions I do, and I will now, with my new project, mill them across one by one, clean them, add the documentation, clean them, add the documentation. Now, you might notice that a lot of the functions I've given you in the past have Roxygen already. That's because then if I ever decide to make it a package, I don't have to. If I'm going to add comments, I may as well add them in a form that can become the help files almost instantly. So I now comment all my functions with Roxygen from the start. So here's the parts of the documentation. You add a title, you add a gap, and then you add a description. You put your parameters in, you return, and you add your examples. Just so I can show you what the examples do, is what this means now this is loaded, is if I go example, and I call it, the function's called my mean, and run it, it runs here, the example's given here. So I must admit, how I actually write my functions is I write my functions, I have a load of little test things here so I can keep running it, testing it. Once I'm happy with that function, I just move them up there and put a hash dash in front of them. So, as you said, to use the Roxygen, you have to let it know, which we just did. So, we have a package that has a single function in there and a description file. The problem with each of them functions is it tells you how to use that function. It doesn't tell you how to use your package together. A lot of modern packages now have a thing called a vignette. And a vignette is just a way of going, here's like a workflow. Here's an example description of me using my functions. So it's like a little mini tutorial. So people, when they get your package, instead of just having to go through every function and try and work out how to use them, this nice little thing that just says, actually, I'd load data this way, I'd clean it this way, here's my functions being used. So it's called a vignette. So we're going to create a vignette. We've used this. So you go back to I'm in my John O'Mean. I go down here and I go use this, use vignette, and I'm going to give it a name. My sample mean. Hit return, and what it's done is it's done a couple of things. First of all, over here, it's added in a new folder called vignettes, and within that folder, it's set me off. It's got a title, all the stuff, and if I go inside, it's called mysamplemean.rmd. So this is just R Markdown. And standard R Markdown, it looks a little bit different at the start, but that's just so it can load into the vignette structure. I can go and knit it, and I can get, in this case, it just loads it. And I could actually use it. So I'm gonna, as I said, you can download this on the web page. I'm gonna go to mysamplemean.rmd. I'm gonna copy that to save me doing a lot of typing. And I'm going to build it. And you can see here is my little example. I load the package, I create some data, I'm using the myMean function. The myMean function will take a numerical vector, I can put maths in there, return the sample mean, here's an example. We can check that this is correct with blah, blah, blah. Really, really useful. It makes a big difference. They've really started to appear over the last 5 years. You'll see a lot of vignettes. And often if you just search on the internet for a particular package and vignette, they'll get the details. Now, the thing is, that's not automatically going to be available to people from GitHub. If people are going to use your package you've got on GitHub, you need to tell them if they want to see the vignettes, they need to use the command dev tools install GitHub build vignettes equals true. And in fact, let me just check that, because I think I added some stuff in my workshop that actually now okay, let me just actually build this and use this version of my So there's the thing we said, there's the stuff we did. So we can actually see the vignette in the package, we're not going to use that button. If you just use the button we've been using all along, you're not going to see it, which is going to be a bit disappointing. So we're just going to quickly go back here, and instead of building it with the button like we did before, here. So what I mean by that is if I go to build and I click install and restart, it will do the usual thing. But when you go to your package and you go to your John O'Mean, you're not seeing any vignettes here. All we've got is description, so you need to build them. So what you do is you go dev tools. Let me get the command right. Install.
John, why are you doing all this stuff in the console?
Because you're actually building things. So it's much, you don't really want a script file because you're only going to do this once. So it's one of the few times I use the console is when I'm doing at that higher level. So if now I run this, what you're doing is you're doing a bit of a more fancy install. No, you can ignore that. So it's a little bit more of a hardcore build. So now if I go to packages and it works, it doesn't always work. But you now see it says here, notice that this extra lines appear, the use guide. And if I click on that, now my vignette is actually in the package. I forgot, there's an extra bit here with the new notes. If you go use this use package and you add a package in here, it will add it to your description file. So if your package uses things like ggplot or some of the other ones, you can actually force that to be in your description file. And what that means is when people install it from GitHub, they'll also install the dependencies.
So where would you put the use package?
Okay, so let's say I wanted in here. So if we look at the description at the moment, it just has at the moment ggplot, Nita R Markdown. Let's say I need dplyr. I would go use this, use, oh, what was it? Use package, wasn't it? Use package. And let's say I want dplyr. Adds it in.
So then when it runs your function automatically down to make sure dplyr.
Yeah, when you build it, it says, yeah, you need this.
So then in your function myMean, will you have to library dplyr, or will it already happen?
I think it already loads it. Depends on whether you have, there's different ones, there's import, suggests, and depends. I think depends automatically loads it. Imports makes it there. I don't know, go and look at, search online on the R packages by Hadley. It will tell you. That I can't remember. There's different thoughts, there's imports, depends, and suggests, and I can't quite remember the difference between all of them. Sorry about that. Okay, so we have a function, we have a vignette that describes that function. The problem is we're all prone to tinker. And we're going to go back, we're going to start tinkering with our thing, and we're going to break things. So we're going to have some unit testing to ensure that whenever we change things, we can just test to make sure things are still working. Okay? So for every function you have in there, it's really good to have a set of test files that will make sure it does what you expect it to do. So we're going to do this in a two-step. First of all, you're going to set up the folder structure with this command. So if we go into our John O'Mean and use this command, now when we go to our files, you'll notice that hopefully there's a new thing called tests. And now we're going to add files within that. So we're going to add one to test myMean. So at the moment, if we look in tests, there's just a test that file and a thing called test that just runs them, doesn't do anything. If I now run this one, you should find now that within here, you've got a new file called test myMean. And it just gives you an example of what it should look like. So again, if we go back to the ADS and have a look in my package material, test myMean, I'm going to copy these across and explain it. So, what do test functions do? Well, first of all, you've got a context. Context are just like section headers. It's just if you're going to have lots of test functions, when they fail, it's really nice to go, actually, I was looking at this. So in this case, I've got my context is the myMean function. I'm just saying this is the code that tests myMean. And I'm going to test something, test that, and again, I give it a little subheading. I'm going to say that it's calculated correctly. Because I might want to test things like, does it calculate correctly? Does it have the correct warnings and errors and stuff like that? But then I can just give some code to test it. So within the braces, I've got code. And you have a lot of expects. So what you do with expects is you say, do this, and compare it with what I expect. So you might say, for example, in the first one, do the myMean on the values 1 to 10. I expect that answer should be equal to 5.5. Fine. The next thing here is I go, right, I'm going to take an x, I've created an x that's got a missing value. And I expect an error. I expect that my mean should now return NA. That's my error equivalent. And you can build up a variety of things. You can say, I expect it to be within this value, I expect this warning, you can test all these things. And you set it up. And you can have multiple of these test that. You can have, in here you can have them both at the same time. You can have multiple contexts. And I would normally again have, maybe one file for one part of my code. How I do it is, I will test things like making sure it calculates things correctly, it has the right warnings. Then every time I get a bug, once I've fixed it, it becomes a test. So if I found my bug always had this problem, then I know I fix it and then I can put test functions in so I don't reintroduce it. So once you've got that, how do you use it? Well, you go back to your build, you go more, and you can click on test package. And that will go away and it will just give you a little result. It says, okay, I'm testing the package JohnOmean. My context at this point is the my mean, and there was two things and they were okay.
They were okay.
They're okay. Let's break it. Let's assume that for some reason it should have given me 4.5 here. Now when I test the package, it runs it, and it comes back and it gives a report. It says one was okay, one failed. Where was it? Well, it was in the calculated correctly subsection. And what was the failure? It was my mean 1 to 10 was not equal to 4.5. Actually, it's out by 1.
That's very handy.
Yeah. And the nice thing is you can actually, so now I'll put this back. You can set it. You can now test it, all fine. I think as well you might be able to configure it so it automatically runs the tests each time. Maybe not. What does it? Does it automatically do it? I think when you run check, which is a more high level one, I won't run it because it takes ages, it will actually run your test functions as well. You've fallen over, haven't you?
Yeah.
That's better. So you can actually use Command-Shift-T. I can't on my computer because I've overloaded that shortcut key. Okay, so we've got functions, we've got documentation that describes the function, I've got vignettes that describe your package and how to use it, we've got testing, unit testing to make sure everything's fine. Unit testing is the most useful thing that none of us does. When I'm being a good coder, I write unit tests. When I'm being a really good coder, I write my unit test first and then I write my code. That's the times I've done that, my life has been sweet, but I'm just not that good. But unit tests are the thing that we don't teach you, you learn to do it, it makes your life so much better. Anyone who's doing big code in their honours or MPhil, if at any point you have more than 3 functions, start writing unit code. Because at some point, I can tell you now, you'll have a function that calls a function that calls a function, and someday, usually about half an hour before your supervisor meeting, your code just shits itself and gives up. And now you have to start searching inside code, inside code, inside code. You don't even know where the problem is, never mind how to fix it. Test function now means you just run it and it goes, right, function number 6 failed, now you know what to fix. You only need to do it once and it starts paying. So, next thing we're going to do is we're going to put data into our package. And I'm going to do 2 sorts of data. I'm going to take my raw data, so I've got it, I'm going to put that in the package, so in the future I've got the raw data itself. I'm then going to write some code that will clean that data, and then it's going to put it in a place that when people come and type the command data and the name of the file, they have that data as a data frame automatically. So, but the reason I put the raw data in is it's a nice self-contained package. In the future, if I want to add more data in or clean it a different way, I can just update it. The raw data will be there for everyone to get if they really want to, but they normally don't have access to it because they don't know where to look. And what I mean by that is there is a folder you can do called inst, I-N-S-T. And that's just almost like, the drawer in your house where you have everything that won't go anywhere else. That's the R package equivalent of that. You put stuff in there, and when people download your package, it usually gets downloaded and shoved away. No one ever knows about it, but you can put a lot of extra stuff in there. It's really good as a developer because you can put all the extra bits in there, know that there's always a copy of it, and you can always convert it later. So here, what we're going to do is we're going to have a folder called xData, so external data, in inst. So to do that, we go to Jono's mean. We go to the central thing, and I'm going to create a new folder called inst xData. And we've got inst, and inside inst, we've got xData. And what I'm going to put in there is I'm going to put the World Cup results for all the data. So if you go back to your workshops, package material, you should have a thing called, where's my World Cup data? That's not the one I want. There we are, World Cup. So I've got this CSV, which has every single country in the 2010 World Cup. By World Cup, I mean soccer. In case anyone has any other idea that there might be any other World Cup. Idiots. And then we've got information about games played, goals, stuff like that. So I'm going to take that, and I'm going to copy it, and I'm going to go to my desktop, my Jono's mean. I'm going to go into inst x, and I'm going to put a copy there. It's all ready to go. So we've got our data in there. What are we going to do? We're going to use this command. I'm going to say use this, use data raw. I'm going to copy. I'm going to go into my Jono mean and run that command. And almost nothing appears. It's just made this. Okay, so it doesn't look very good. Where does it put it? If you go, you'll now see this thing called data raw, and inside you've got this World Cup 2010.r. What this is it's set you a folder up. And what this folder is going to do is you can write your cleaning data. You can write everything in here to manipulate and clean that data set. And then the final command here says use this use data World Cup 2010 is you're going to take an object at that point and you're going to save it in the right place, this command will, so when people use the package they can get to it. Okay? So let's do that. So we go back to Jono's cheat file. Not that one, this one. So I'm going to copy, go back to that folder we just created, and have a look at it. So the problem with that data you noticed is, to me it was the wrong way around. Each subject was a country, and we had these variables, but it was a transposed form of the data frame. You had the variables as rows and the countries as columns. So here's my code. First of all, it reads in the CSV, in next data, there's the World Cup, and we have a look at it. So let's do that. So we'll run that in, and here's my World Cup, like that. Then this one probably won't work on your system because you don't have the latest version of tidyr, but it will take that World Cup data, it will grab it, pivot it longer, pivot it wider. So basically it is just it's now converted it so you have the names here and your various values. I don't like this being called name, I want it to be country, so I convert that to country. And now I've got this World Cup 2010, so let's have a look at it. Being awkward now. So this isn't the clean form I want. I want to save that into my package. So if we just have a look here, you can see there's nothing in here except for this folder. If I now use this command, absolutely nothing appeared, because where it's put it is if you go here, there's data, there's your, and it saved it as an RDA. So it's this three-part process. The first folder we created takes your external data, your raw data. Then we have another folder called raw data, and I don't like the way they've called it that, but that's what they suggest, that has all the folders, the structures that will clean the data. Then I use the command here. So I take that and I say use this data, so it's going to save it under the same name in a place I can now get in my package. The overwrite equals true is there just because when I was testing it, I wanted to keep changing it and overwriting it, and it will come. If you don't do that, it won't save it again. It's being protected with your data. So overwrite is true just says overwrite it. So now, when we've done all that, if I now do my install, and now if I go, I will make sure that everything's cleared to show that it works. So I'm going to clear this. My environment's clear. If I now go data, World Cup 2010, it's got a promise. It means, yeah, I found it. It's all ready to go, but I'm not going to load it unless you really need it. And if I now go World Cup 2010, there's the data. So you can share data around. Now, how am I going to document my data set? Well, the nice thing is you can still use Roxygen. But what you do is to do that is, first of all, I'm going to create myself a new standard script as if I was writing a function. And I'm just going to take my manual here and I'm going to copy that in to my new script. I'm just going to save that. Doesn't matter on the name, but I'm going to save that in where my R functions go. So I'll call it World Cup. So it looks like a broken function. So what I've done is I've got here, you can see it's Roxygen. I've got my title, I've got a description, I've got a new thing here called @format, which lets me tell you what the information is. I've also put in @source URL. And then the key thing at the end of it, in quotes, you have to put the name of the data frame. And what this will do is it will realize that there isn't a function there, it's associated with something else, in this case the data frame, and it will produce that help file. So now when we do so hopefully to show that it works, if we look here and look at the John O'Mean. At the moment you see there's no help page for the World Cup Soccer. Now if I build it, and if it works, there's now the World Cup 2010, and when I click on it, it gives you the information, etc.
Where do you save the file you just made?
In the R file.
In the R one?
Yes. So as I said, it looks like a function without the function there. So all documentation of functions go in the R. So we have our package. We've got our function in there, we've got a vignette, we've documented it, we've added some data, we've got the raw data in there, we've got code that cleans it, and we've added documentation. And we're so proud of this, we want the rest of the world to know about it. So how can we get that out there? Now you can put it on CRAN, in the same way as you could go home tonight, get yourself a shovel, and keep hitting yourself in the face with the shovel until you bleed a lot. As long as it's gone through CRAN, I highly recommend you don't do it. Unless you're in that sort of thing, then good luck to you. I'm happy for you. But even better, get it on GitHub. GitHub's great. You can get it out there. You don't have to go through all the hoops that you need. And it means the world can now use your code and help you improve it. That's what I'm going to call the internet. It'll help you improve it. Sometimes by laughing and pointing, but generally going to help you improve it.
So CRAN's how you get the installed packages thing.
Yeah. Yeah, there's two main repositories for official packages. CRAN, and there's also the bioconductor. Bioconductor makes CRAN look like a cuddly teddy bear that gives you flowers. Bioproductor is seriously hardcore.
So they have like really tough reviewers and stuff.
It's not reviewers that have tough. So to Crown, there's actually a process you go through. I'm not going to go through it.
Yeah.
But you upload it, and you have to do things like you have to send it off to another server that builds it into a Windows machine to test it works. And then it comes through all these various steps, and then you have to go through all these questions. You have to have news files and that. And then I did it once, and then I got an angry letter from Douglas Bates, one of the top guys in R, just to go, well, I don't think blah blah blah. But it is a hard process. GitHub is nice and easy. I will show you how to do it on GitHub. So, do it on GitHub, and there's other things you don't have to use GitHub. If you don't like GitHub, there's Bitbucket, there's Gitbucket, there's various other online repository resources for Git. I put resources on Slack on Git what it is, but basically Git is version control. Gives you the ability every so often just to take a snapshot and store it on your computer, but then take that snapshot and put it somewhere else so it's safe. The advantage is, because of the file structure, if you put it somewhere else where it's somewhere safe and it's public, other people can now install your package and use it. And it's not that hard. Now, there's lots of different ways you could use Git. The one I'm going to use is, I'm going to use Github Desktop. So Github Desktop is a free app that's available, produced by GitHub. There should be one for Linux, Windows, and Mac. So first of all, I need to let GitHub Desktop know about my new package. Okay, so easy enough. I'm just going to go File, Add Local Repository. And it goes, where is it? And you basically show it the folder it's in. So if I go to Desktop and Jono's Mean, I say, this is the folder, and I click Open. And then it says, look, there's a folder here, but it doesn't seem to be a Git repository, because what a Git repository has, it has some hidden files inside, which is basically storing all the information about the snapshot. It says, you haven't got that yet. So you just click the Create a Repository here. You give it a name. You can have things like gitignore, which says, I don't care if this file changes, don't save a copy of it. You can do things like, there's different ones for C, etc. Different languages. So for R, I can put an R one in. I can choose my license. We said we went for the GPL version 3, etc.
Wait, does that mean it'll ignore your R?
No, it will ignore all the helper file structures in R that we don't need, but it won't ignore your R. So people have standard things you can ignore for standard languages. So, for example, if you're doing C++ and you're compiling it, it won't save your .so.o files. It will only save the source code. You click Create Repository, and that's it. If you look, it's actually done everything. It's taken it, and it's committed it automatically. It took everything in there, and it's saved it. It's taken a snapshot. So what you can do now is you say, well, actually, I want to publish this. So you can either click Publish Repository, or you click it, and it says you'll have to log in with your GitHub account. But then it says, fine. Do you want to publish this? Do you want it private or not? You don't want yours private. And you click Publish. Yeah, I've already got that one. Let's call it Jono Mean 2. And it's gone and it's doing it at the moment. It's fetching, it's doing various things. It's all good. If I want to see it on the internet, if I go repository view on GitHub, there is my stuff. If people wanted to use it, they would go DevTools, GitHub install, jono2/jonomean2. Let's say I change things. So let's go to jonomean, and we decide in my mymean function to put some extra stuff in here. So I don't know, print n. You save it. You build it. You do all this thing. Remember, at the moment, it doesn't know about them changes in Git. So you can do a two-step process. You're going to take a snapshot to your local system, and then you say upload that to GitHub. So you go back here to wherever I've put it. And if you look at changes, it says, oh, look, there's been a change. It's actually highlighted it for you. You've added this print n. So, first of all, you know, up here it's giving you a default update, but I could actually put more information. Added print. You can commit to master. That just means take a snapshot here. takes the snapshot, and now my local Git has been updated. And you should just be doing that all the time, but every so often you want to basically, it's called push origin. That is basically saying, take that changes and change it on GitHub. If you're not using Git at this point, at some point in the next 12 months, your life will be slightly worse. I can tell you now. The things that you should learn as you're now a researcher is version control. It doesn't have to be Git. It could be Subversion or something like that. But it's one of these things, if you don't have it, you'll regret it. Every student, if you talk to Matt Rowan, has a free GitHub account. The university has bought a load of copies for you. You can keep all your code private if you want to. The nice thing is, where it gets really useful is, let's say I've deleted a file. I force you to delete a file, and then next week your professor, your token professor that you're in charge of, says, you know what, I really like that function. I know I said delete it, but it was brilliant. Get it back. You go to GitHub and you can find your functions and you can copy and paste it back. Or you can actually, there's commands that will let you restore individual functions, stuff like that. I highly recommend, if you learn nothing from today, you get the message of go learn Git. I put lots of resources on Slack for you. Have you already learned that valuable lesson?
Jono, you said
He uses Git regularly.
Uni gets a free Git account?
No, everyone in the School of Maths.
Okay, so I thought it was already free.
There is free ones, but not for unlimited private. The school has bought extra ones, so you can pay extra. So public is fine, it's free. But private accounts, that is, I want somewhere to store my stuff and I don't want the world to see it, it's limited. We have bought you a whole set for the school, so you can have all your work there as a private repository. All you have to do is talk to Matt Warren. When I say all you have to do, I realise that that's not the easy. He'll tell you a story about the good old days.
Yeah, Microsoft bought GitHub, and now you can get more private, free things.
Yeah.
It's changed, but you can definitely do a lot more with the premium version. If you do talk to Matt Ryan about GitHub, he will lecture you about how good GitHub is as you're asking for more GitHub.
You think my spiel is you go, oh, Jono went on. No. This was the warm-up act. This is just the stand-up comedian that says, hey, take my wife, please. You still got to go through the proper Matt Ryan. I do recommend that. I recommend you start putting your code in packages quite early. The problem with most research in statistics, it's all paperware. People have good ideas and they put it in papers and that's it, and no one uses it. One of the most highly cited papers in statistics is a paper on basically modulating t-tests to take into account large data sets. No one cares about it except for the fact that Gordon Smythe and Terry Speed made it into an R package called Limmer. Everyone in bioinformatics until recently used Limmer, and every person who used Limmer cited that paper. That paper has had 3,800 citations. I haven't done it, but you can, in your package, you can do a citation function that says, please cite me when you do it, and it gives you the command to do. But your work is completely useless until other people use it, and they will use it if you give them the software to use it. I think it's important enough to actually have a section in my CV just of software that I have. The other advantage is, if I go to get another job, how are they going to know if I can code? I have a whole set of code they can see. So I go, here it is, have a look. I had a very nice guy from, he was either one of the top guys in Google or the top guys in Microsoft, I can't remember, contact me via email, me and Matt, to talk about the package we'd written on containers. You know, he wouldn't know me from Adam. And we had a very nice email conversation about the work. So, very worthwhile.
You're not ditching us, right?
Oh God, no. I love this. Cool. That is it. You've got the workshop, you've got everything to go through. The other resources is Hadley Wickham has a book called Our Packages. It's freely available online. It's a bit outdated now. A lot of the things that used to be, that we used this, used to be in dev tools, and there's been a move across to this. If you have any problems, come and see me. As always, thank you very much.